Welcome to Lesson 8.5, Writing and Graphing Exponential Growth Functions. In this video, we're going to talk about how to write and graph functions that have to do with exponents. So first, let's just define exactly what an exponential function is. So an exponential function is a function that's in the form y equals ab to the x power. So right here, where a does not equal 0 and b is greater than 0 but cannot be 1. All right? They are non-linear, meaning they are not straight lines. All right? So, for example, we have been working a lot with linear functions. So functions like this, which would often look like, a straight line up or a straight line down or, like this, somewhere along those lines where you have everything is in a linear form, okay? In this particular section, we are going to be talking about um, exponential functions. These functions look a little bit different and they have a different relationship. So instead of having like y equals mx plus b over here, we have the y equals a times b to the x power. Okay, so these functions often look, or always look, like this, where they're curved, or they look like this, where they're curved down. Okay? Um, so today what we're going to be focusing on is how to find a function rule given some information, like a table like this one. And we're also going to be talking about exponential growth. All right, so we'll have two different parts to this section. So the first thing is if we wanted to write a rule for the function. So let's say I have my x values are -2, -1, 0, 1, and 2. And my y values are 2, 4, 8, 16, 32. Right away, I want you guys to focus on this aspect right here. Whenever x is 0, the y value is going to be very important to us. All right, so we are going to, I'm just going to break this down. I'm going to show you all the steps, but I'm going to walk you through them all. So because this x, when the x is 0, the y value that it appears, so in this case 8, is going to be our a. So we have my y equals a b to the x power. My a is going to be this y value. So immediately I have y equals 8 and then times whatever my b is going to be. All right? So I want you to look right away. We want to figure out if it is an exponential function. And how we do that is we figure out, for example, the y values are multiplied by 2 in this case. They're increasing by 2. So if you went from 2 to 4, you're multiplying by 2. 4 to 8, multiplying by 2, so on and so forth, okay? So that tells us, because it's being multiplied by 2, that is giving us our b value. So we have our a value, which is 8. Now we have our b value, which is 2. And we're going to go to the x power. All right, and we know this is true because if I were to plug in one of my x values here, I could say, for example, y equals 8 times 2, and let's just use to the -2 power. Well, in past lessons, we have learned that if we have an exponent that is negative, my whole exponent's going to go to the bottom. So I could say y equals, and I have 8 on top, because that doesn't change. But my 2 to the -2 power is going to become 2 squared, and it's going to go on the bottom. If I were to solve this, 8 stays on top. 2 to the 2nd power is the same as 2 times 2, which is 4. 8 divided by 4 is going to be 2. So when my x value is -2, my y value is 2. All right, so my answer for this particular question, writing a rule for the function, would be this formula right here. All right, so let's look at another example. So if I have this function right here, this table of information right here. So first off, I want to figure out whether or not it's exponential, okay? So I'm going to look at my y values, and I'm going to notice something. The relationship between 3 and 9 is multiplied by 3, because 3 times 3 is 9. From 9 to 27, it is also multiplied by 3. All right, and I'm going to check to make sure that 27 times 3 is 81, and it sure is. So we're finding that each step, as we go up one value, because if you notice these just go up one value, that my y value is being multiplied by 3. This tells me that this is in fact a exponential function. So I'm going to have y equals, and I'm putting it again into my a b to the x power, where my a is my y value when x is 0. So I'm going to look for that value, so that's 27. And my b value is what it's being multiplied, what the y is being multiplied by. So in this case, it's 3 to the x power. So my answer would be y equals 27 times 3 to the x power. All right, so now that we know how to figure out and write the rule for an exponential function, we're going to talk about graphing it. So if we wanted to graph the function y equals 2 to the x power, and then identify its domain, its x value, and its range, its y value. All right, so there's a couple steps that I'm going to be doing here. So the first one is I'm going to make a table by choosing a few values for x and finding the values of y. So I am going to create my table, and I have my x values. I'm just going to continue with the same pattern, -2, -1, 0, 1, and 2. It's a really good rule to follow. All right, and then I'm going to start plugging this information in. So into the original equation. So I have y equals 2 to the -2nd power is going to become 1/4. 2 to the -1 power is going to become 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the 1 first power is 2, and 2 squared is 4. So I'm going to take this information, and I have x, y pairs. I literally have things to graph here. So I am going to take this information and I'm going to graph it on a coordinate plane. All right, so I'm just making my window here dual monitor so I can see what I'm doing. And so I have, again, my x and y table, and I'm just going to go through and I'm going to start graphing. So I've got -2, 1/4. So I'm going to say it's about there. All right, then I've got -1, 1/2, a little bit higher, 0, 1, right there, 1, 2, and then 2, 4. All right, and then I'm just going to draw my curve between these lines. And there I have graphed successfully an exponential function. Notice how it curves upward and it goes positive. All right, if I wanted to continue by identifying its domain and range, which is the second part of this problem, I want to look at the domain. So that means I want to look at my x values. And I'm going to look here and I'm going to notice that my x values and my y values, because this is a function, if you see, it's going to, my x values, so this, they're just going to keep going this way forever and ever and ever, and then this is just going to keep going this way forever and ever and ever. So that means that my x value is going to be all real numbers. So I could say my domain is just all real numbers. And I am also noticing that my y value, if you go up here, it's going to keep going up and up and up and up and up forever. Okay, so my range is also going to be all real numbers. All right. All right, so that's how you would graph an exponential function. So let's just put my thing back to single page, and we are going to move on. So the second part of my of this lesson is about exponential growth. Exponential growth is basically talking about talking about a model or a function where you are going positive the entire time. So our exact definition for exponential growth is when a quantity grows exponentially. It increases by the same percent over equal time periods. All right, so we're going to take that same idea of the y equals a times b to the x power, only we're going to make b something different. My a is still my initial amount. That is still my amount when everything is at 0. Okay, but then my b now becomes 1 plus r, where that 1 plus r is my growth factor and r is my growth rate, meaning that if I have something growing at 10% increase every year, my growth rate would be 0.1 because it would be 10% and I'm just turning it into a decimal. All right, and then my x now becomes t, and t is for the time period, so how long we are measuring the exponential growth by. So let's use this formula in a word problem. So it says the owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in 1984 when its value was $11,000. The value of the car increased at a rate of 6.9% per year. They want you to write a function that models the value of the car over time. And then the second part is in B, it says the auction took place in 2004. What was the approximate value of the car at the time of the auction? So run your answer to the nearest dollar. So we're just going to look at our A part first. We're going to write a function that models the value of the car over time. So remember again that I have the formula y equals a times 1 plus r to the t power. All right. And I'm going to start plugging in some information I know. So right away, I know that my A value, my beginning value, is going to be what the owner bought the car for. So that's that $11,000. I also know the rate. The rate is 6.9%, which I can rewrite as a decimal, which would be 0.069. All right, so the first thing I'm going to do is I'm going to plug that into my formula. So if you look down here, right here, I plugged in all my information. I don't know in A what the time period is, so I'm going to keep T as just T. Add my 1 plus 0.069, and this right here is going to be my formula. And I would say you would even want to put, they put C, you can put Y, whatever you want to choose for that. It's fine. Um, So that would be part A. Part B is just going to start plugging in some information. We know that the car or that the auction is going to take place in 2004. He bought the car in 1984. So we want to think about how much time has passed to actually plug in the information for T. So how much time has passed between 1984 and 2004 is 20 years. So 20 is going to go in for my T, and then I'm just going to solve. So I'm going to multiply, or first I'm going to do 1.069 to the 20th power. If you're typing this into the calculator, it's really important that you figure out this first and then multiply it by 11,000. And then your answer will come out correctly. And in this case, it's about 41,778. It said round to the nearest dollar. That's why we don't have any cents. I'm assuming this probably, if you typed it into a calculator, came out with a bunch of decimals afterwards and we just rounded. So the value of the car in 2004 is going to be $41,778. All right. The last piece of information that I have for you today is talking about compound interest. And compound interest is interest earned on both an initial investment and on a previously earned investment. Okay, so this can be modeled by exponential growth, where A is the initial investment, R is the annual interest rate, and T is the number of years. So I'm going to look at a problem here that I have. And it says you put $250 in a savings account that earns 4% annual interest compounded yearly. You do not take any deposits or withdrawals. How much will your investment be worth in 5 years? All right, so I'm going to take that same formula I've been using, that exponential growth one, y equals a times 1 plus r to the t power. I'm going to start plugging in my information. I know that $250 is my initial amount, so that's going to go in for A. I know that my annual interest is 4%, which is my rate, so that is going to become 0.04. And so that is going to plug in for my R. And I want to know how much it's going to be worth in 5 years. So that's going to be my T. So I'm going to plug in all that information, and then I'm just going to solve. 1 plus 0.04 is 1.04. That to the 4th power, I'm not sure what that is, but I'll figure that out. And then I'm going to multiply it by 250. My answer is going to be 304.16, which is $304.16. So in this case, my answer would be B. All right, that's all I have for you. I know this was a long video, but a lot of information for it. Okay, let me know if you have any questions. Thanks.